Hello, this is going to be a real short video. We are extending our ideas on energy, conservation of energy, and work, and now we are adding power to it. So just write this down in your notebook. We're just going to have this brief page here and then 2 example problems that will help you out on your homework. So power, what is it? It is related to work. So power, by definition, is the rate at which work is done or the rate at which an external force changes the energy of the system. So basically, how quickly do you do work? An example is if you were to walk up a flight of stairs, you're going to do the same amount of work regardless of how fast you get up to the top, because you're going to apply a force to carry your weight over the distance of those stairs. And so work is force times distance. Regardless of how fast you move, you're going to do the same amount of work because you're going to have the same amount of force over distance. But if you run up the stairs, obviously it's a lot harder to run up the stairs than it is to walk up the stairs because you're more powerful when you run up the stairs. The rate at which you do work is quicker, right? You get to the top faster, so you do the same amount of work in less time, so you're more powerful. Looking at the definition, right, power is just work over time, or the symbol for work, right, capital W over time. And the units for power are watts, and so you're going to have a capital W for watts. That can confuse people a little bit because your equation is going to be capital P equals capital W over T, and the capital W in that equation is the variable for work, but then once you get your answer, you're going to put another capital W, and that capital W is a unit of measurement for watts. So keep those two straight. We're going to go over 2 examples. You might want to consider pausing the video so that you can write down the question, and then you can hit unpause and we can work through that problem. Okay, so looking at this, we have a 2-kilogram box is lifted at a constant speed. If it's lifted at a constant speed, we know the net force is 0. Therefore, the lifting force is equal to the weight of the box. So if the weight of the box is 20 newtons, then the force that you need to lift it is also 20 newtons. We have the box is lifted 4 meters in 8 seconds. So A, how much work was done on the box? So what we know is the mass, the distance it was moved, and the time. We know that the work that we did on the box is the force that we pulled up with over the distance that we pulled up on it. So we know that, as I said before, the force that our lifting force is going to be equal to the weight, and we moved it 4 meters vertically. So we did 80 joules of work. Now, regardless of how fast or how slow we pull that box up those 4 meters, we're going to do 80 joules of work. The difference is, for power, how quickly did you do it? So using our new equation for power, right, work over time, we did 80 joules of work in 8 seconds. Make sure your unit of measurement for time is in seconds as always. So 8 divided by 80, 10 watts. So you can see the problems are pretty straightforward and not too complicated. Number 2 is a little bit different. So again, you might want to pause and write this down real quick, and then we can move on. So we have a 4-kilogram box is lifted at a constant speed of 1.5 meters per second. So last time it gave us a distance and a time, and now it's giving us a speed in, sorry, there was a little pause there. So we gives us a constant speed in 1.5 meters per second. So what we're going to do with that 1.5 meters per second is we're going to look at this. This should say 1.5, not 15 here. we we can say that we moved a distance of 1.5 meters in 1 second. We can say we moved a distance of 3 meters in 2 seconds. It doesn't really matter. We're going to end up doing the same. We're going to end up having the same amount of power. Now we would have a different amount of work depending on the distance we moved and the time, but we're going to have the same power. So we know that work is force times distance and power is work over time. So what we're going to do is we're just going to combine those together and substitute in, instead of putting in work, and you could calculate it out separate, right? We can just combine it, put in the FD into that equation, and then we can then start plugging in our numbers. So we know that the force, again, is going to be equal to the weight because it's at a constant speed. So the weight, the force that we apply is 40. If I choose my 1.5 meters in 1 second, then my distance is 1.5 and my time is 1. I could change this distance to 3, change the time to 2. Either way, I'll come out with the same answer. It's not going to matter. Right? Oh, sorry, the distance, yeah, the distance would be 3, not 2, and the time of 2. So you can see either way, you're going to get the same power rating of 60 watts. And that is it for our video.